Welcome to Science at the Library. Today we're going to be looking at three liquids and how they are different and how they might interact. Water, alcohol, and oil. And so that we can get an idea of what kind of molecules these are, I drew a little diagram. You may remember from last time we talked about water having two hydrogens and one oxygen atom, and the oxygen's quite large and negatively charged, so it makes water very polar, and it also has a lot of hydrogen bonding going on, so the hydrogens of one molecule can bond to the oxygens of another. And it's a weak bond, but it does give water certain important properties. The alcohol, and we're using rubbing alcohol, which is isopropanol, has carbons and hydrogens as well as an oxygen. So it is also fairly polar, but not as polar as water. And then oil is just a long string of carbons and hydrogen atoms. So it's not polar at all, very nonpolar. Okay, so we're going to do three experiments. We're going to first look at what happens when we mix water and oil together. So I've got some water here with food coloring in, and we're going to add some oil. And whenever you do a science activity like this, you want to kind of make a hypothesis, an educated guess about what you think is going to happen. So one thing I know is that water's polar and oil is not, so I don't think they're going to really want to mix. But then if they form two layers and don't mix, we have to figure out which layer we think is going to be on top. So take a second and see if you can figure that out, and then we're going to test your hypothesis here. I'm going to pour some oil in, and we'll see what happens to it. Okay, so you can see that the oil stayed on top. So what that means is that water is more dense than oil. So if we have a spoonful of oil and a spoonful of water, the water's going to weigh more. And that's why oil is less dense and it forms a layer on top. Okay, so we're going to come back to that and see if we can get them to mix in a minute there. But in the meantime, we're going to look at water and alcohol. So I've got some more water with food coloring in. And now we're going to add alcohol. Now we know that both alcohol and water have some polarity because of that oxygen atom. But the question now is, what are they going to do when we mix them together? So let's see here. Try to do this carefully. Okay, so you can see that there's a lighter blue layer on top, and in fact it's kind of clear at the top, but a lot of mixing is going in, mostly because I poured it kind of fast. But it shows that that water and alcohol are actually quite happy being together. And you can see, well, it's hard to see, but at home you can probably see, if you let it be real still, that you can see some kind of wavy lines as it mixes together. So we're going to set that one there for a minute. And then the third pair we need to do is alcohol and oil. And for this one, I put some alcohol in the bottom, and I put some a little bit of red food coloring in it, turned pink. So the food coloring does dissolve in the alcohol. And now we're going to put some oil in. We know that water is quite dense. It's more dense than oil, and you can see a little tiny layer. So water is also more dense than the alcohol, but which is denser, oil or alcohol? Let's see if we can find out. I'm going to pour some oil in here and try to do a good job. You can see that the oil is forming a kind of yellowish layer at the bottom. So oil is actually more dense than the alcohol. So if we were to rank them from least dense to most dense, we'd say alcohol, then oil, and then water. And the reason why water is so dense is because it really does form a lot of those hydrogen bonds, and the molecules pack very closely together. And so an equivalent amount of water weighs a lot more than either oil or alcohol. Okay, so now we're going to see if we can force these guys to mix up better. So this is the oil and water, and it's kind of like salad dressing. So I mixed them, and they form an emulsion, which means they do mix together, but they don't actually form a solution. So you can see almost immediately that the oil is separating out in the top again, and the water is separating, staying at the bottom. And in the middle, you kind of have a messy layer of a bunch of air bubbles and oil and water that hasn't quite separated out yet. So it's just like when you put your salad dressing in the fridge and it sits for a while, it separates out, if it's oil and vinegar at least. So that's separating back out, because water and oil really hate to be together. So water and alcohol, though, we saw that they were already mixing, so let's go ahead and see if we can get them to mix. You see, so no layers at all now, and the blue is spread through both. So this is a solution, and we can let it sit forever, and it will never separate out again, because alcohol and water are very happy to be together. So then the only one to look at here is alcohol and oil, and these two, I'm going to shake up and then let it sit, and you can see that it's staying mixed a lot longer than the oil and water did. And it's kind of milky, so it's not a true solution. It's more of a what they call an emulsion. It's two liquids that aren't that happy being together, and you force them to mix by, in our case, stirring it real hard. And so it will eventually separate out more. We'll take a look at it maybe at the end and see. But while we're letting those things do their job, I wanted to show you what happens, like say, if you mix all three together. And this is a little trickier to get it to work, so I did it ahead of time. I just wanted to show you that if you take the alcohol and the water and you mix those together, and then you add oil, if you have them in just the right amounts, you can get the oil. I don't know why it's so cloudy. It was clear at home, but anyways. You can see those oil balls just kind of floating in there. Mm-hmm. And they kind of go up and down, but depending on the temperature, but right now they're kind of floating in the middle toward the top. I'm going to put another bit of oil in there and show you. So, let's see what happens. Okay, put it in carefully there. So you can kind of see it's going to go, and it's going to so it's kind of hanging in the middle. And so oil is not going to mix in with those, even though it's pretty happy being with just alcohol, and it's really not all that happy being with a mixture of alcohol and water.
So if you put in another spoon, it would just make its own bubble? Like they'll stay separate?
Yeah, probably.
Oh, that's cool.
Let's see. Yeah, I was thinking they would join up, but they don't really seem to. Oh, that one didn't seem to do much of anything. Uh-oh.
Oh, there goes one.
Yeah, so anyway, that's kind of cool. So that's where you've got you're making the density just right so that the oil will kind of sink and go in the middle. Because when you take something real dense like water and something less dense like alcohol and mix them together, you get something with a medium density in it. Okay, so that's kind of fun to play with at home. And you might take, if you're doing this, you might take your water and alcohol and your water and oil and mix them together and see what happens. Or if you're pouring real carefully, you could get 3 layers. You could get water in the bottom, oil in the middle, and alcohol on top. Okay, so then it's kind of fun to play with a bigger jar of this, and I'll have this nice glass thing with water on the bottom and some oil on top. And I'm going to try to be really careful and put some food coloring in. And we know that food coloring is not going to dissolve in the oil. So it should just sit at the top there. Up top where the oil and the water
That's so
meet.
Cool.
And put some blue in. They're just going to sit there for a while. And eventually they will go down into the water. Okay. So let's see if we can get them to go down into the water. Oh, there they go.
Oh.
There goes some. I'm going to try to get more to go down in there. So I'm just putting some salt in, and that kind of hits that weighs down the bubbles when they go
That's really cool.
in there. And so the food coloring is pretty heavy, so it goes down to the bottom and then it kind of mixes around. Oh, that's really dark. But you can see the salt kind of pushing it down a little bit. Okay. And last but not least, we're going to try putting in some Alka Seltzer. So this is soluble in water, but not in oil, so it should drop down and then hopefully start to bubble.
Oh.
And as it starts to bubble, it's going to carry the color up and mix it more. See, let's put more. More is usually better.
Oh, that's so cool. Look at that center.
So, yeah, so you see a big, so it's going to carry the water up, and then when it gets to the oil, the air continues up, but you'll kind of lava lamp up there.
That's neat.
Blue? Yeah, and so when the bubble busts up through, it kind of carries some oil, and that's why it looks kind of murky, and then it'll settle down maybe.
Those layers are still staying separate.
Yeah.
That's for sure.
Yeah, so that's kind of the idea with a lava lamp. You have heat moving blobs of wax through water, and gives you that cool effect. So anyway, you can
A little frothy up there too.
yeah. So that's pretty much our activity for today. You can see the water and oil now is separated out pretty much. There's still a little cloudiness there, but it's pretty much back to where it was. This is still a solution, so it's completely mixed. And then this one,
Oh, it's trying.
it's trying. Yeah, you can see it's the yellow kind of the oil is kind of cloudy. It's probably going to take a good day to settle out completely. And when I did it before, even after a day, it was still a little cloudy. So that's it for liquids that mix and don't mix, and then different densities. So have fun and let us know if you discover something really exciting with this activity. And we'll see you next time. Bye.